So before I started my video, I would like to introduce with you guys and explaining with you guys what is a hydraulic jump, since our video will be showing an information about a hydraulic jumps. So a hydraulic jump is a phenomenon in the flow of liquid typically occurring in open channels flow, such as river, spillway, wastewater treatment system. It involves a sudden transition from high velocity, low depth flow, which is known as a supercritical, to low velocity, and lastly high depth flow, which is known as a subcritical. And this transition creates a turbulent region with a significant energy dissipation, and hydraulic jumps are important in engineering dissipation. This is because of the sediment control and mixing purposes. However, they also pose a certain safety risk which need to be managed effectively by the community itself. For answering the question 1, which is to find the calculation for the depth before the hydraulic jumps, energy loss and power loss. So for the first question is, indicate a uniform water depth of a rectangular earthen channel with E 3 meter, use base to convey Q 20 meter, discharge with a Manning coefficient and same to 0.025. Channel bed slope is 1s, 1 in 250. So to answering this question, first of all, we have to listed all the information that was given in the question, like Q equals to 20, N equals to 0.025, and then for bed slope is 1 over 250, B is 3 meter, and then for B formula is 2D. So first of all, we have to look for the area, and then formula for the area is B times D, and then we use this B formula, which is 2B times with D, and then the answer would be 2B square. And then next step, we have to look for the R, and then R is A divided with P. So here we could use that 2D square over HD, and then the answer would be 1 over 2D. And then to get P, which is the third step, is B plus 2D, and then equals to 2D plus 2D. And then for fourth step, which is Q, A times with 1 divided with N, and then times with R 2 over 3, and then times I 1 over 2. So here's the formula, and then we have to fill all the number that we present in the formula, and then the answer that we will get is 1.99 meter.
Seterusnya saya akan explain untuk soalan 2. Okay, question 2. A sluice gate discharge water into a horizontal rectangular channel with a velocity of 10 meter per second, a depth of flow of 5.5 meter. So, Q sama dengan 10 meter per second, and depth of flow dia 5.5. So, tinggi dia dah bagi. So, untuk kira specific energy head, E sama dengan Y tambah V2 bahagi 2G. So, Y kita 5.5, V kita 10. So, 5.5 tambah 10 kuasa 2 bahagikan dengan 2 darab 9.81. So, jawapan dia 10.6 meter. Seterusnya, to find the critical depth, YC. Untuk cari YC, kita akan guna formula V2 bahagi G kuasa 1/3. So, YC 10 kuasa 2 bahagi dengan 9.81 kuasa 1/3. So, jawapan dia kat sini 2.17. Okey, seterusnya untuk kira minimum value of the specific energy head, E min sama dengan 3 bahagi 2 darab dengan YC. So, kat sini YC kita adalah 2.17. So, 3/2 bahagi dengan 2.17. So, jawapan dia adalah 3.255. Okey. Next, I will pass this calculation to Izmi Haziq.
Seterusnya adalah critical field velocity, dan velocity sama dengan punca kuasa 9.81 darab dengan 2.17, dan kita dapat VC kita adalah 4.61. Dan seterusnya kita pergi ke the flow, whether the flow is subcritical ataupun supercritical. V sama dengan 10 dan VC juga adalah 4.61. V lebih besar pada VC dan dia adalah the flow is supercritical. Supercritical flow is a state of fluid flow in open channel where the flow velocity is greater than the wave speed, and in this state the flow is characterized by high velocity and low depth.
So for the next slide, to answering the question 2, we have to, every of the member have to present one ethical consideration that was listed in the question. For me, I was choosing ethical consideration for public safety. So first of all, the point was environmental impact, public safety, and equitable water resource allocation. So, what kind of accident was happening? The effect of hydraulic jump into the public safety. First of all, because of the drowning hazard. So this can be happening with the turbulence in the hydraulic jump create strong current and vortices, making it hazardous for swimmer and water. The sudden change in water can also lead to unexpected condition that can trap or overwhelm the individual that was in the water. And then next point is structural integrity. So the turbulent forces and pressure fluctuation in a hydraulic jump can cause wear and damage to concrete structure and embankment. For example, the continuous monitoring and maintenance are required to prevent structural failure. So for the other next point is debris accumulation. So debris accumulation is when the floating debris can accumulate the turbulent zone, posing risk to infrastructure and blocking water flow. And accumulate debris can also become hazardous projectiles during high flow events. And then last one is environmental impact. Turbulence can lead to resuspensions of sediment, affecting water quality downstream. And then the mixing effect of a hydraulic jump can also influence aquatic habits by changing oxygen level and temperature profile. So, how can we overcome this problem of hydraulic jump that can affect to the public safety is, first of all, we can do the physical barriers and warning sign. So this is by install fences, guardrails, and clear signage to keep the public away from area where hydraulic jump occur. So use buoys and marker in the navigable water to alert water of the danger. And then next is for the engineering control. Engineering control is by designing channels and spillway to safely manage the energy dissipation associated with the hydraulic jumps. Use energy dissipation structure like sealing basin to control the hydraulic jump location and reduce its intensity. And then the third one is what we can do to overcome this problem is that regular maintenance and inspection. So by conduct frequent inspection of structure affected by hydraulic jumps for sign of wear, erosion and damage. And it also can implement maintenance schedule to address minor damages before they can become a major issue.
Okay, next is environmental impact. So, first is hydrological changes. Variation in the amount of water moving downstream can affect the overall water balance, rates of erosion, and the transport of sediments. Changes in the timing of peak flow, which can be brought on by dam operation in climate change, can have an impact on the seasonal mating cycles of aquatic species and the availability of water for plant. Okay, next is water quality. Variation in water flow can have an impact on the river thermal regime, which can harm species that are sensitive to temperature. Lower flow can cause pollution and nutrient concentration to rise, which would be bad for the health of aquatic life and the quality of the water. So next is aquatic and riparian ecosystem. The distribution and abundance of aquatic and riparian species can be impacted by changes in the flow, which can also change the habitat condition. Change in flow can affect the number of food supplies available.
Equitable water resource allocation is crucial topic in both academic literature and practical policy making. So schools have explored various approaches, including water rights system, market-based mechanism, and community-based management model to ensure fairness and sustainability in water distribution. So additionally, interdisciplinary research often examines the intersection of water allocation with issues such as social justice, environmental conservation, and economic development.
Okay, for example, principle of fair distribution. Make sure that the distribution of water resources promote fair economic opportunity and meets fundamental human needs. Water should be distributed in a way that promotes ecosystem health and long-term availability. Encourage the effective use of water resources to reduce waste and maximize benefit. So second is public awareness and education. Create educational initiative to inform the public about the value of fair water allocation and water conservation. Make certain that all stakeholders have access to information regarding water resources and management technique. Third is allocation mechanism. Establish clear and secure water rights that reflect equitable access. Use water pricing, subsidy, and incentive to promote efficient and fair use. Implement quota system that allocate water based on need, availability, and sustainability criteria.